everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable questions. So let's get going. Problem solve x cube d cube minus x square d square plus 2xd minus 2 into y equals to x cube plus 3x. So here we are given a differential equation with variable questions. Now we are going to reduce this to a differential equation with constant questions by making some substitution. Okay, and also we are given a Cauchy's equation. Solution. Given differential equation, x cube d cube minus x square d square plus 2xd minus 2 into y equal to x cube plus 3x, right? Which is a Cauchy's equation. Now let's make the substitution. Put x equals to e power z, then log x to the base e equals to z for x greater than 0. Let theta equals to d by dz. Here theta is a differential operator with independent variable z. Then xd equals to theta, x square d square equals to theta of theta minus 1 or theta square minus theta, and x cube d cube equal to theta of theta minus 1 into theta minus 2. We know that theta into theta minus 1 is theta square minus theta into theta minus 2 is theta square into theta is theta cube minus theta square into 2 is 2 theta square minus theta into theta is minus theta square, minus into minus plus theta into 2 theta, right? Which is equals to theta cube minus 3 theta square minus 2 theta square minus theta square is minus 3 theta square plus 2 theta. Now the above equation becomes, replace x cube d cube by theta of theta minus 1 into theta minus 2 minus replace x square d square by theta of theta minus 1 plus 2 into replace xd by theta minus 2 into y equal to x cube, replace x by e power z, will get e power z whole cube plus 3 into replace x by, replace x by e power z, right, plus 3z, plus 3x, replace x by e power z. Okay, we'll get theta into theta minus 1 into theta minus 2 is theta cube minus 3 theta square plus 2 theta minus of theta into theta minus 1 is theta square minus theta plus 2 theta minus 2 into y equal to e power z whole cube is e power 3z plus 3 into e power z. Now this equation becomes theta cube minus 3 theta square plus 2 theta minus theta square minus into minus plus theta plus 2 theta minus 2 into y equal to e power 3z plus 3 into e power z, right? Plus 2 theta minus, so we'll get theta cube minus 3 theta square is minus 4 theta square plus 2 theta plus 2 theta plus theta is plus 5 theta minus 2 into y equal to e power 3z plus 3 into e power z. So we have reduced the given differential equation to an equation with constant questions, and also this is in operator form f of theta into y equals to some function of z, right? Which is in operator form f of theta into y equals to some function of z, where f of theta equals to theta cube minus 4 theta square plus 5 theta minus 2. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yb. We'll find yc using the auxiliary equation. The auxiliary equation is f of m equals to 0, where f of m equal to, we have f of theta, theta square minus 4 theta, theta cube minus 4 theta square plus 5 theta minus 2, right? Let's replace differential operator theta by m, so that we'll get f of m equals to m cube minus 4m square plus 5m minus 2. Now, our auxiliary equation becomes m cube minus 4m square plus 5m minus 2 equal to 0. Now, we can find roots using synthetic division method. Let's place the constants of the equations. Let's place the equations of m cube, m square, m power 1 and m power 0. Minus 2, 5, minus 4, 1. Now let's see which m satisfies the polynomial m cube minus 4m square plus 5m minus 2. Okay, firstly I'll go for m equals to 1. We'll see for m equals to 1. I'll get 1 minus 4 plus 5 minus 2, which is equals to 1 plus 5, 6. Minus 4 minus 2 is minus 6. 6 minus 6 is 0, right? When m equals to 1, 1. When m equals to 1, or m equals to 1 satisfies the polynomial given, or this polynomial. 1 into 1, 1. Minus 4 plus 1 is minus 3. 1 into minus 3, minus 3. 5 minus 3 is 2. 1 2s are 2. Minus 2 plus 2 is 0. Again, this gives one more polynomial. M square minus 3m plus 2. Right? We can see which m satisfies this equation. Let's try for m equals to 1. We'll get 1 minus 3 plus 2 equals to 3 minus 3 equals to 0. So m equals to 1 satisfies this polynomial. 1 plus 0, 1. 1 into 1, 1. Minus 3 plus 1 is minus 2. 1 into minus 2, minus 2. 2 minus 2 is 0. See, this gives a factor. M minus 2. Okay. From m minus 1, we'll get from m equals to 1, we'll get m minus 1 equals to 0. Again, here m minus 1 is one factor. And also, here also we'll get m minus 1 equals to 0. From this, we'll get m minus 1, one more factor. So, the polynomial can be written as product of m minus 1 into m minus 1 into m minus 2. Right? Or, see, from here, we got a polynomial, right? M square minus 3m plus 2 equals to 0. Just find factors. You can write minus 3m as minus 2m minus m plus 2. Now take m common from the first two terms, we'll get m times m minus 2. Now take minus common from the next two terms, we'll get minus of m minus 2. Right? Then m minus 2 into m minus 1. So these are the two factors from the second polynomial, right? We can just write m cube minus 4m square plus 5m minus 2 equals to 0 as product of 1 and 2 factors. Right, then m minus 1 into factors of this polynomial is minus 2 into m minus 1 equals to 0. Okay, or directly you can write this. Then m equal to, now equate each factor to 0. Since m minus 1 is repeating twice, when m minus 1 equals to 0, we'll get m equals to 1, and when m minus 2 equals to 0, we'll get m equals to 2, right? Since m minus 1 is repeating twice, so 1 will be 2 roots and another root will be 2. When m minus 2 equals to 0, we'll get m equals to 2, another root, right? So we got 2 equal roots and 1 distinct root. Therefore, the first two roots are equal roots and 2's are distinct root, or real and equal and distinct. Okay, 2 real and equal roots and 1 real and distinct root, we can say. Now let's write complementary function. We know that when two roots are real and equal, say m1 equals to m2, then yc will be c1 plus c2z into e power that equal root into z, and for a distinct root, say m3, yc will be c3 e power that distinct root into z. Now coming to our complementary function. So firstly I'll go for the equal roots. Yc equals to c1 plus c2z into e power that equal root into z, plus now I'll write for the distinct root 2, another constant into distinct root into z. This equals to c1 plus c2z into e power z plus c3 e power 2z, right? Now we are having yc in terms of z, but we need to write in terms of x. So what I'll do, I'll just write e power 2z as e power z whole square. c1 c2z into e power z plus c3 e power z whole square, right? Now replace e power z by x and z by log x. Then this equation becomes yc equals to c1 plus c2, replace z by log x, will get c2 log x, and replace e power z by x plus c3, replace e power z by x, will get c3x square, which is our required yc. Let's now go for yp, particular integral. We'll find yp using 1 by f of theta into q of z, where f of theta is theta cube minus 4 theta square plus 5 theta minus 2, and q of z is e power 3z plus 3 e power z, right? We can write it as 1 by f of theta into e power z plus 1 by f of theta into 3 e power z, or we can write this term as 3 into 1 by f of theta into e power z. Okay, first term will be as it is plus 3 into 1 by f of theta into e power z. Now let's find each term separately for our convenience. First one, 1 by f of theta into e power 3z, right? So this is of 1 by f of theta into e power az form, right? And f of theta is theta cube minus 4 theta square plus 5 theta minus 2. Now compare e power 3z with e power az. Then for a equals to 3, we'll find f of a which is equals to f of 3. Just replace theta by 3 here. We'll get 3 cube minus 4 of 3 square plus 5 into 3 minus 2. This is equals to 3 cube, 27. Minus 4 into 3 square, 9. Plus 5 3s are 15. Minus 2. This is equals to 27. Plus 15. Okay. Minus 4 9s are 36. Plus 15 minus 2. This is equals to 27 plus 15. 42. Minus 36 minus 2 is minus 48. This is equals to minus 6. Non-zero. Sorry. Here minus 36 minus 2 is 38. Okay. I'm sorry. So 42 minus 38 is 4, which is non-zero. Since f of 3 is non-zero, so we'll replace theta by 3. Then we'll get 1 by 3 cube minus 4 into 3 square plus 5 into 3 minus 2 into e power 3z. This is equals to 1 by 3 3s are 9, 9 3s are 27 minus 4 into 9 plus 15 minus 2 into e power 3z, right? This is equals to 1 by 27 plus 15 is 42. Minus 36 minus 2 is minus 38 into e power 3z. This becomes 1 by 4 into e power 3z, right? 42 minus 38 is 4. Now we are having this in terms of z, we need to write in terms of x. So what I'll do is we'll just write e power 3z as e power z whole cube. Now replace e power z by x, then we'll get 1 by 4 into x cube, which is equals to x cube by 4, or 1 by 4 into x cube. So the result obtained from the first term is 1 by 4 into x cube, right? Now let's go for second one. 3 into 1 by 4 of theta into e power z. And this is also of 1 by f of theta into e power az form. We have f of theta, theta cube minus 4 theta square plus 5 theta minus 2, right? Now compare e power z with e power az, then for a equals to 1, we'll find f of a, which is equals to f of 1 equals to, replace theta by 1, we'll get 1 cube minus 4 into 1 square plus 5 into 1 minus 2. This is equals to 1 minus 4 plus 5 minus 2. This is equals to 1 plus 5, 6 minus 4 minus 2 is 6. 6 minus 6 is 0, right? If we replace theta by 1 here, we'll get 3 into 1 by 0 into e power z. Since 1 by 0 is undefined, so total term becomes undefined. So what we have to do? We should not replace theta by 1 here. This is equals to 3 into, write 1z into 1 by, find derivative of f of theta. If f of theta is theta cube minus 4 theta square plus 5 theta minus 2, then f dash of theta will be 3 theta square minus 4 to the 8 theta plus 5. Now find f dash of 1. 3 into 1 square minus 8 into 1 plus 5 equals to 3 minus 8 plus 5 is equals to 8 minus 8, which is equals to 0, right? Fine. Now just write derivative of this, f dash of theta here. 3 theta square minus 8 theta plus 5 into e power z, right? Since f dash of 1 equals to 0, what we'll do? We'll just write 1 more z into 1 by, write the derivative of f dash of theta. So we need to find f dash of theta here, which is equals to 3 to the 6 theta minus 8 into e power z. See here we are having minus 8. So definitely by replacing theta by 1, we'll get a non-zero term in the denominator. Okay. See, f double dash of 1 equals to 6 into 1 minus 8 equals to 6 minus 8 equals to minus 2, which is non-zero, right? Now replace, since f double dash of 1 is non-zero, so we'll replace theta by 1. Okay, this equals 3 into z square into 1 by 6 into 1 minus 8 into e power z. Since f double dash of 1 is non-zero, so we'll replace theta by 1, right? Then this becomes 3 into z square into 1 by 6 into 1 minus 8 into e power z. This equals to 3z square into 1 by 6 minus 8 into e power z, which is equals to 3z square by or into 1 by 6 minus 8 is minus 2 into e power z. We can write it as minus 3 by 2 into z square e power z. Now we are having in terms of z, we need to write in terms of x. So what we'll do, we'll just replace e power z by x and z by log x. Then we'll get minus 3 by 2 into, replace z by log x, we'll get log x whole square into, replace e power z by x, right? Or we can write it as minus of 3 by 2 into x into log x whole square. This is the result obtained from the second term. Now coming to yp. Yp becomes, result obtained from the first term is 1 by 4 into x cube plus result obtained from the second term is minus of 3 by 2 into x into log x whole square. So this is our required yp. We are having yp and yc. Now let's write the general solution. The general solution is given by y equal to yc plus yp. Then y equal to yc, we are having c1 plus c2 log x into x plus c3 x square, and yp is plus 1 by 4 x cube minus 3 by 2 into x into log x whole square. This completes the problem. So we have seen a problem from higher order linear differential equation with variable questions in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.